I will talk about containers and our journey with Docker so far. So let's see. Before I begin, let's try to understand what are the containers. It's basically offer OS level virtualization, so you can run multiple applications on single host. So there are a couple of implementation for containers exist, as you know, as we know, like some of them listed here. Most common I can find myself is LXC and LXD. So let's look at how they are different from typical virtual machine, if we talk about. So here is a diagram I have actually. So you have infrastructure layer, then we have host operating system layer, then we have hypervisor. Basically the role of hypervisor here is to manage the resources within your infrastructure. And then we have virtual machine, each block of virtual machine which carry its own OS, and then application is deployed on top of it. So this is how typical virtual machine architecture looks like. On the other hand, we have container architecture, which is we have infrastructure layer, then we have operating system layer, then we have container engine. So the role of container engine here is to share the system operating system resources and kernel. So we can run multiple containers on single host, like these are the container blocks, for example. But as you know, it's not been easy to use container technology or consume it until Docker comes into the picture 3 years ago. It's an open source project, as everyone knows. So what Docker allow us to, they build some tools so that we can easily consume the container technology. So what that does is it helps us to package our application with all its dependency into single unit file. So what it means, you define everything in one file and you take it from there. So one file is nothing but your Docker file. You define everything how it should be built up. So let's look at a bit core components of Docker. There are 4 core components. First one is Docker image, which is basically a snapshot of your application which will be deployed as a container. Then Docker container, which is a running instance of your image which you created in first place. Docker engine, it's a runtime to run manage your containers. You can do different operations with engine, like start, stop, or all kind of operations related to containers. And then last is Docker registry, which is basically help you to ship your Docker images to either your public repo or private Docker repo if you have one private Docker repo. So why we decided to use container actually, Docker containers more specific? Because they are very lightweight. According to Docker philosophy, we try to run single process in container, so that becomes very lightweight. Portable, it can run anywhere, either on public clouds, providers, bare metal, or even on laptops. Easier to deploy. Service isolation, because you run single process, so that help us to isolate your service a bit. Ideal for continuous delivery scenario, what it means, the typical use case, if you have microservices based architecture, it's you want your service to deploy more efficiently and as continuous as possible, so that it helps us a bit on that. Cost efficient, because we can run many containers on same machine. But there are some challenges with containers. If we talk about scalability, example deployment at scale, how to manage hundreds or even thousands of containers, how to ensure availability of your containers. Imagine if you have how to ensure that your container is always up and running at any point of time, and how to ensure that if you have more containers running for your application, how to load balance them in a good way. Container intercommunication, typical example for this, if you have 2 containers, one is application container and one is database, and if you want to connect, if your application container want to talk to database container, how you achieve that intercommunication. Persistent storage, similar like previous example actually, if your database container, your data should be persistent enough, so if the container gone away, your data should not be lost. So how to ensure that persistency? So in order to overcome these challenges or solve these challenges, We evaluated a couple of tools out there in the market, and we decided to use Kubernetes, which is basically orchestration platform for automating deployment, operations, and scaling of containers. So how it helps us to achieve that actually? Because of some of the features they have. The most critical features we really wanted is like service discovery and load balancing. Imagine if you have thousands of containers or hundreds even, we want to service discovery for those and load balancing for those as well. Horizontal scaling is also one of the important feature to scale up and scale down your containers. Whenever there is a need, we need to come scale up the containers, and when there is no need for it, then we should scale down as well. Automated rollout and rollback is also one of the critical feature we really want if you want to go production with containers. Like in order to release your services with newer versions, like rolling updates specifically, as well as blue-green deployment, that's also a very common factor. And then secret and configuration management is one of the also important feature which really needed, like more specific, like as the Docker images are immutable, they can run anywhere, but how to handle environment specific configuration like your staging and QA and dev, how to ensure that all the environments get their respective properties or environment specific parameters. So using configuration management feature, we can achieve that in a good way. So the last thing I have actually on my slide is continuous integration and continuous delivery workflow with containers, which is also important for continuous deployment for microservices. So as a developer, you commit a code and push to your Git repo, which you are working on. The next thing happen in like your Git repo trigger a commit webhook, which is normally listened by your CI tool. Whatever CI tool you use, like Jenkins in our case, then it performs some different operations after that. Like it try to build your service, and then it try to run some test after that. Then it will try to build Docker image and push it to Docker repo, and if everything goes successfully, then it will try to redeploy your service to respective environment like dev, QA, prod example. And this last step can be either automated, or even you can just press the button whenever you want to deploy something more specific for production. You still don't want to do automated sometime. So the question to answer, like, is life easy with Docker containers so far? We think yes, and I think we should start with simple project and try to use it and improve on that, and then try to use for other projects as well. Thank you.